9.7 Taylor polynomial and approximation. So the first definition is the definition of n Taylor polynomial. We will go to this later, right? So the definition is if f has n derivative at c, then the polynomial, this will be the calculation of it. So basically, if you take derivative, you have to take derivative n times. Before I go to the theorem here, I'm just going to explain from the example, will be easier. So let's say you want to find the nth Taylor polynomial centered at C, and this is your function. Your n is 3. When n is 3, it means you want to take derivative 3 times, the third derivative. And C is 8. Alright, so look at the formula. I have f of c, okay. I'm going to start from f of x. So my f of x is cube root of x. So cube root of x, I rewrite it as x to the 1/3. Then you're going to take derivative 3 times because my n is 3 here. So the second derivative, I just bring the 1/3, so x to the negative 2/3. I take derivative again, 1/3 times negative 2/3 is negative 2/9, x to the negative 5/6. Then the third derivative, I multiply negative 2/9 and negative 5/3. I get 10 over 27 times x to negative 8 over 3. So that is the take derivative 3 times because n is 3. Now c is 8. So I'm gonna put 8, replace x everywhere. So if I replace 8 here, I will have 8 to the 1/3, which is mean cube root of 8, which is 2. Second derivative I have is here, so it's going to be 1/3, 8 to the negative 2/3. Then I bring it down to keep it positive. So 8 to the 2/3 is mean cube root of 8. Cube root of 8 is 2 and square is 4. So I have 1/3 times 1/4, which is 1/12. Now second derivative, I do the same thing. However, 8 to the 5/3 is cube root of 8 is 2. 2 to the 5th is 32. So I multiply these two terms. I have negative 1 over 144. Now the third derivative, again I have 8 to the 8 cube. 8 raised to 8 over 3. So same procedure. I will get this number. Now, since I have all these little pieces, then I'm going to put in the formula and explain to you. So f of c, my f of c is 2 right here. I have 2. All right, plus f prime of c. So my f prime of c is 1 over 12. That's my 1 over 12. Times x minus c. X is x, c is 8. So x minus 8. Maybe I should go up here. Yeah. Next one is the second derivative of c. My second derivative of c is, I did all of this, is negative 1 over 144 right here. X minus c, x is x, c is 8, square, then I have square, divide by 2 factorial. So if it's square, divide by 2 factorial, if it's cube, divide by 3 factorial, and so on. If it's n, divide by n factorial. So I'll go to the third one. My third one will be 5 over 3,456, x minus 8 quantity raised to the third over 3 factorial. So I'm just follow the definition here, all right? But before I do that, I would suggest you find each definition first and then put it together. After that, I simplify, and this is the final answer. All right, let's look at the next one. Hi everyone, let's look at the next theorem, which is Macaulay. When you let c equal to 0 and substitute in this theorem, you're going to end up with f of 0, f prime of 0 times x, f double prime of 0 times x squared over 2 factorial, f third derivative of x to the cube over 3 factorial, and so on. So this is called Macaulay polynomial of f. Alright, let's look at example. They want you to find the fifth Macaulay polynomial of the function e to the negative x. So I'm going to find the derivative first. So this is our original function. first derivative, I'm just going to have e to the negative x times negative 1. Second derivative, I'm going to have e to the negative x. I have negative already, times negative. It's going to be positive. So it's going to be e to the negative x, alternate positive and negative. Alright, so now if c equal to 0, if c equal to 0, you're going to have e to the 0, which is 1, negative e to the 0, which is negative 1, and will be alternate 1, negative 1, 1, negative 1, and so on. So now we have all the little pieces, just put it in here. F of 0, my f of 0 is 1, alright. F prime of 0, f prime of 0 is negative 1 times x, right here. F double prime of 0 is 1, x squared over 2 factorial, and then the third derivative will be negative 1, x to the cube over 3 factorial, and so on. And if I simplify this, f of 0 is just 1, this term become negative x, this term become x squared, 2 factorial is just 2, minus x to the cube, 3 factorial is 6, plus x to the 4th factorial is 24, minus x to the 5th, 5 factorial is 120. Alright, we finished 9.7. See you next time.